Hey class, Mr. M here with our video on the segment addition postulate. Sounds fancy, but it's actually very, very simple. So let's break this down a little bit. A segment, of course, is part of a line. So something like this would be a segment, of course. Addition involves things being combined. We know that. Postulate's a word you may not know. What is a postulate? A postulate is an assumption, simple assumption usually, right? It's an assumption. So basically the segment addition postulate is this, and I'll show it to you in pictures. If you have a segment, I'm going to call it x, z, and you have a third point somewhere between, and I'll talk about that word in a moment, between those two, let's call that y, all right? Then the segment addition postulate says this. Y is between x and z, then xy's length plus yz's length is equal to xz's length. Which if you think about it makes perfect sense, right? Imagine you're starting at point x and your destination is point y. Sorry, point z, okay? Well, you travel this distance and stop for gas or get some snacks or whatever, and then you travel the rest of the distance. So you're just breaking it up into two parts. So I'm going to call this segment here orange, xy. So xy's distance, right, is just part of the way. And then this next part I'll do in green, yz, right? So when you combine the orange distance and the green distance, you have the full red distance, xz, right? Again, just common sense, but it's a useful idea. Now the word between is an important one. Between implies, meaning it assumes, that we're talking about collinear points. So when you see the word between, here we're talking about point y is between x and z on the same line, collinear. Okay? So if y is literally in the same line as x and z but between them, then you have this simple relationship where orange part plus green part together makes the red part. Okay? So why is this useful? Let's take a look at an example. A, B, and C are collinear points such that C is between A and B. If AC is 12 centimeters and BA is 20 centimeters, find the length of BC. Okay, well, the first thing for any geometry problem when there isn't a picture, by all means, draw one. So here we have a segment. We know that A, B, and C are in the same line, so they're going to live on this, such that C is between A and B. So our segment is actually AB, and somewhere in between it is C. It doesn't say it's in the exact middle. Maybe it is, but not necessarily. So notice that between does not mean in the middle, okay? It means literally between. Is this picture to scale? No, not necessarily. It may not even be a representative, but it'll be useful for us to understand. Okay, so if AC is 12 centimeters, so this part right here is 12, and BA, okay, BA is the whole thing, isn't it? If BA is 20, so from A to B or B to A is the whole thing is 20, the question is, find the length of BC. Well, BC is just this part right here, right? Now hopefully you can just look at it and get the answer, right? The whole thing is 20, part of it's 12, that's the rest of it. But, so if you can do that, great. But if you're having some trouble, if you're not immediately seeing it, well, the postulate says that the red part plus the green part, which I'm going to call just question mark here, we don't know what it is going to equal the whole thing. That's the exact same postulate we saw a minute ago. Or to put it in algebraic terms, 12 plus unknown is equal to 20. Well, use the simple laws of algebra, and x is equal to 8. So our unknown length is 8. 12 and 8 makes 20. There you go. There's a segment addition postulate. Now, this algebra method here seems like overkill, right? If you can look at 20 and you can look at 12 and immediately know the missing part is 8, awesome. But it's not going to be as obvious in the next example, okay? So keep this basic idea in mind as we approach the following. T is between S and U. Pause, right? No picture. That's a problem. Draw one. You got S, you got U, and T is somewhere between them, right? Remember, between already means in the same line. So collinear, that's between them. All right, ST is some unknown number minus 6. So x minus 6. St, we're going to call x minus 6. And Su, which again is the whole thing, right? Su is the whole thing, and that's 10. The question is, continuing. Tu is 2x minus 8. So Tu is just this part, right? So Tu is 2x minus 8. So all this is right here is simply a visual representation of the first two lines, right? It's a picture version of the words. The question is, find the length of St. Well, we obviously know it's going to be less than 10, right? It's just part of that orange 10. So our question is, how much is it? Well, here we can't just look at it and get the answer. So we have to make an equation. We have to use the idea that the whole, the entire line, right, is the sum or addition of its parts. The purple part and the green part together give you the total orange part. Okay, so let's make an equation. X minus 6, which is just part of the line, combined with the other part of the line, which is 2x minus 8, equals the entire line, green and purple together make the entire orange, which is 10, right? So to go one step further, this right here is the text. This right here is the visual, and this here is the algebraic. Different representations of the same information. Well, once it's in algebra form, we can use the rules of algebra to help us. We have here what are called like terms, right? They both have the same variable to the same power. And of course, these are both numbers. They happen to be whole numbers, and that's also useful. So let's combine like terms. X and 2x makes a total of 3 x's. Negative 6, take away 8, is negative 14. On the other side, we have 10. Our goal, one of our goals is to get x equals something, right? So I need to isolate this x variable right here. So I'm going to add 14 to cancel this. But to balance my equation, I've got to add 14 to both sides. Negative 14 and 14 goes away, giving us just 3x on the left-hand side. 10 and 14 gives us 24. Well, we're almost at our final step, so simply divide both sides by 3. Is x by itself? Absolutely. Divide both sides by 3, and we get 8. Is the answer 8? No. X is equal to 8. Well, the question is not what is x. The question is find the length of St. Well, now St is findable. Simply take the value of 8, plug it in for x. So if St is x minus 6, we now know that x is really just 8. So 8 minus 6, so St is simply 2. A lot of work just to find 2, but let's briefly review it before we move on. We have the verbal, right, which is these two parts right here. We have the visual, the representative part. And then finally we have the algebraic part. We solve the algebra, simply a multi-step equation, finding our unknown. Our unknown allows us to find the known, which is just 2. Now this idea extends more to than just segments. It also extends to angles. So we have also the idea of angle addition. So let's do an example real quick. Point D lies in the interior of angle ABC. I don't see angle ABC, that's a problem. Let me fix it. Here's angle, right? So this is the vertex, the middle letter, so A to B to C. Now just use common sense. Interior means inside. So somewhere inside this span, right, this span right here, somewhere inside of there lies point D. So it doesn't matter where you put it, let's put point D right there. Might not be to scale, but that's okay. If angle ABD is 25, so already they're saying we have another angle, ABD. So from A to B over to D, it's telling us that is 25 degrees. And CBA, okay, where's CBA? CBA, well that appears to be the whole thing, right? CBA is 65 degrees. The whole thing is 65. And part of it, right, this black part over here is 25. The question is, find the measure of angle DBC. D to B to C. Well, once again, let's think. The whole thing is 65 degrees. 65 degrees is the entire angle. And it is made up of two parts. The part here in black and the part here in red. Well, the black part is 25 degrees. And combined with the red part, which we don't know, let's call it X, we have the whole 65. So black and red makes orange, red and black together, added, right, makes orange. So now this becomes a very easy problem. Take away 25 from both sides, and we get 40 degrees is our unknown angle measure. 40 and 25 makes 65. Okay, hope this helps, and I'll see you in class tomorrow.